At first, Shubho Kali Chaturdashi to everyone. Wishing you and your family a very prosperous and happy Kali Chaturdashi and Kali Puja. Okay? Today, I will say system of linear differential equation. This is today's goal of this lecture. How look like the system of linear differential equation? Dx dt equal to ax plus by and dy dt equal to cx plus dy where a, b, c, d are real constant. This is look like system of linear differential equation. Here capital A equal to a, b, c, d. Then dx dt equal to a, b, c, d xy. That imply x dash equal to x. This is the matrix representation. The question is such type. Find out the general solution x dash equal to ax. And this one, if lambda 1 and lambda 2 are two distinct eigenvalue, then the general solution of linear system would be x equal to c1 v1 e to the power lambda 1 2 plus c2 v2 e to the power lambda 2 t, where these v1 e to the power lambda 1 t and v2 e to the power lambda 2 t, two linearly independent eigenvector, and c1 c2 are arbitrary constants. First question which had come CSIR NET 2012 exam. The question is dy dx equal to ay. This is the system of linear differential equation where given here initial condition y0 equal to 2 minus 1 and here given the matrix, and where y equal to y1x y2x. Then we have to find y1x tends to infinity, y2x tends to 0 as x tends to infinity. Here at first we have to find the eigenvalue. This is the first condition. Here a equal to 1 to 0 1. Since this is the upper triangular matrix, so eigenvalue are lambda equal to 1 and minus 1. And since this is the eigenvalue, then we have to find second condition, we have to find the eigenvector. For lambda equal to 1, 0 to 0 minus 2 xy equal to 0 0. That imply 2x equal to 0 and 0x plus 2y 2y equal to 0, that imply y equal to 0. Since here given y equal to 0, that means x is arbitrary number. Consider x is 1. Then v1 would be 1 0. If we consider, since x is arbitrary number, we can also choose C, but for short calculation here choose 1. Next, for the eigenvalue lambda equal to minus 1, a equal to 2, then 2 0 0 xy equal to 0 0. That imply x plus y equal to 0 and x plus y equal to 0 imply x equal to minus y. That imply v2 equal to 1 and minus. The solution is x equal to c1 10 e to the power x plus c2 1 minus 1 e to the power minus x. That imply this is equal to c1 e to the power x plus c2 e to the power minus x minus c2 e to the power minus x. That means y1 equal to c1 e to the power x plus c2 e to the power minus x and y2 equal to minus c2 e to the power minus x. And here the initial condition y0 equal to 2 minus 1. That means y1 0 equal to 2 and y2 0 equal to minus 1. Since here the solution is this, just put the initial condition. Since y1 0 equal to 2, that means just put x equal to 0. That imply c1 plus c2 equal to 2 and second condition y2 0 equal to minus 1. y2 0 equal to minus 1, that imply minus c2 equal to, since y2 0 equal to minus 1, minus c2 equal to minus 1, that imply c2 equal to 1. Since c2 equal to 1, that means also c1 equal to 1. Therefore, here the arbitrary constant c1, c2, the value is 1 and 1. Therefore, the solution would be, since x equal to c1 e to the power x plus c2 e to the power x and here minus c2 e to the power x, that means the solution would be x equal to, since the value of c1, c2 1, e to the power x plus e to the power minus x minus e to the power minus x. Condition is when x tends to infinity, then here y1 equal to e to the power x plus e to the power minus x and y2 equal to minus e to the power minus x. Since when x tends to infinity, then when x tends to infinity, then y1 tends to infinity and y2 tends to 0 because this is e to the power minus x. So option 1, this is 1, 2, 3, 4. Option 1 is right option. Second, when x tends to infinity, then y1 tends to 0, y2 tends to 0. This is the wrong option. Next, third, when x tends to minus infinity, then x tends to minus infinity, then this part would be 0 and this would be minus infinity, this would be tends to infinity. That means y1 tends to infinity and y2 tends to, this would be e to the power plus infinity, here minus 1. That means y2 tends to minus infinity. So y1 tends to infinity, y2 tends to minus infinity. This is right option. And here given y1, y2 both tends to infinity when x tends to minus infinity. This is the wrong option. So option 1 and option 3, these are right option. I hope my all viewers have understood this type of question. This type of question actually very easy type question, just conceptual. Second type system of linear differential equation, dx dt equal to ax plus by and dy dt equal to cx plus dy. Here the equation is look like x dash equal to ax, where a equal to abcd. If here second method, since if the eigenvalue are repeated, that means lambda 1 and lambda 2 equal to lambda, means repeated eigenvalue, same eigenvalue, and dimension of eigenspace corresponding to the eigenvalue lambda is 1, then That means there exists for lambda, there exists an eigenvector v1. Then the eigenvector corresponding to lambda is obviously v1. Then construct another eigenvector corresponding to v1 is v2. This is actually the extra condition. Here one eigenvector corresponding to lambda is v1. Now we have to construct another eigenvector corresponding to v1, which would be new eigenvector would be v2. And this is look like a minus lambda I v2 equal to v1. Then we get linearly independent eigenvector, say v1 e to the power lambda t and t v1 plus v2 e to the power lambda t. Then the general solution is c1 v1 e to the power lambda t plus c2 times t v1 plus v2 e to the power lambda t. This would be general solution. And here c1 and c2 are arbitrarily constant. Okay, I hope my all viewers have understood clearly. Next I will see one example. The system of linear equation dx dt equal to minus x plus y and dy dt equal to minus y with the initial condition x0 equal to y0 equal to 1, and this is had come CSIR net 2016 exam. That means here a equal to minus 1, 1, 0, minus 1, and the eigenvalue corresponding to a is minus 1 and minus 1. This is the repeated eigenvalue. That means here the solution would be such type: y1 equal to v e to the power minus 1t and y2 equal to, sorry, here v1t plus v2 e to the power minus 1 times t. So for the eigenvalue lambda equal to minus 1, the corresponding eigenvector would be 0, 1, 0, 0, x equal to 0. That means xy, that means here y equal to 0 and x is arbitrary, so v1 equal to 1, 0, and generalized eigenvector would be a minus lambda I v2 equal to v1, 0, 1, 0, 0, and here v2 xy equal to, here v1 and v1 equal to 1, 0. That means that imply 0x plus y equal to 1. That means the value of y equal to 1. So v2 equal to 0, 1 and v1 equal to 1, 0. Then solution would be y1 equal to v1 means 1, 0 e to the power minus t, and y2 equal to v1t means 1, 0 t plus v2 0, 1 e to the power minus t. That means y2 equal to t 1 e to the power minus t. That means this is equal to t e to the power minus t e to the power minus t. Now notice here The option is given xt equal to e to the option 1 e to the power minus t plus t yt, option 2 yt, option 3 e to the power minus t plus, times 1 plus t, and option 4 minus yt. For this, here not, since here yt, so consider this is yt and this is xt, not y1 y2. For this consideration, consider this is yt and this is xt. Okay, therefore the solution would be, here the question about xt and this is the solution, which we can write, if we common e to the power minus t, then this would be t0. So t1, so option 1 is a right option, e to the power minus t plus tyt. Similarly, yt means 10 e to the power minus t, so this is e to the power minus t plus tyt. Similarly, option 3 e to the power minus t plus e to the power t minus t times 1 plus t. This and this option is right option. I hope my all viewers have understood. This is clearly okay. Well.